Now we're going to look at section 3.2, which is all about the products and quotients of monomials. This section has a lot of properties. Let's go ahead and start. First, we have property 3.1. Property 3.1 says, if b is any real number and m and n are positive integers, then b to the power of n times b to the power of m equals b to the power of n plus m. Basically, we sum the two exponents together. Now, for this entire section, you can prove all of the properties. I'm going to go ahead and walk you through this proof so that you can see the general process. But then, for the rest of the properties, I'm actually going to let you try to prove them, and then you can always check in your textbook if you would like. What does b to the power of n times b to the power of m actually look like using the definition of an exponent? Using the definition of exponents, basically b to the nth power means that we have b multiplied by itself n times, so n factors of b, and then b to the power of m means that we are multiplying it by m factors of b. Think about it. How many total factors of b do we have? That's right. We should have n plus m total factors of b. Now, working our way backward using that definition of exponents, we can actually write this with a single base. This equals b to the power of n plus m, which is the proof of why this property holds true. Let's go ahead and look at a quick example. For our example, let's go ahead and simplify 2x cubed y squared times 3x to the fourth y cubed. Remember, you can use the properties that we've learned about earlier this semester to potentially group things differently. You can switch the order of things differently. Remember those associative and commutative properties we learned. So I'm going to go ahead and switch the order of things so that I can make sure that my numbers are together, my x's are together, and my y's are together, and then I can go ahead and simplify using property 3.1. This is going to give me a final answer of 6x to the 7th, y to the 5th. Let's go ahead and move on to some more properties. Next, we have property 3.2. Again, there are a lot of properties in this section, and as you can tell, they are all very originally named. Property 3.2 says that if b is any real number and m and n are positive integers, then b raised to the power of n raised to the power of m is the exact same thing as b raised to the power of n times m. Basically, power to a power means that you would multiply the two exponents together. Again, I do not plan to prove this in the video, but please try it on your own in your notes using the definition of exponents, and then double check with the proofs in your book. Property 3.3 states, if a and b are real numbers and n is a positive integer, then a times b together raised to the nth power is equal to a to the power of n times b to the power of n. Basically, as long as you're multiplying inside the parentheses here, you can think of it as distributing that n power in. Whatever you do, make sure that you're multiplying inside here and not adding. You cannot distribute a power in if there are multiple terms in here, only to a single monomial, a single term in there. Again, feel free to try to prove this property and then double check your proof with the proof in your textbook. We're going to take a quick break to combine all three properties together and look at an example. I want you guys to take a second and see if you can simplify this product. we have 3 times x to the 5th times y squared times z, all in parentheses raised to the 3rd power, times xy to the power of 4. Pause the video and try this on your own using properties 3.1, 3.2, and 3.3. And when you think you have an answer, go ahead, restart the video, and check your work. So hopefully you got rid of that 3rd power here, the cubing of this entire term, using property 3.3, where you can kind of distribute that in because it's all multiplication. So I have 3 cubed, technically x to the 5th to the 3rd, which then using property 3.2 is x to the 5 times 3. Same thing here, I end up with y to the 2 times 3, and then z cubed. Simplifying that, I get this step where I have 27, x to the 15th, y to the 6th, z cubed. Again, I still have this xy to the 4th hanging out over here. And then I can combine everything using property 3.1 from the previous slide, which leads me to my final answer of 27, x to the 16th, y to the 10th, and z cubed. So that product is my final answer. Nice job. Our next property is property 3.4. This property says if b is any non-zero real number and m and n are integers, then b to the power of n divided by b to the power of m equals b to the power of n minus m. Again, take a second, pause the video, try to prove this, and check with the proof in your textbook. Now what do you think would happen if we have a divided by b raised to the power of n? Look back at your property 3.3 in your notes. Using what you learned with that property, predict what you think this equals. Hopefully, you predicted that you could distribute the exponent in. We have a to the power of n divided by b to the power of n. So that is another non-named property of exponents from your textbook. We're going to go ahead and move on to the final 2 properties of exponents. These as well are not numbered in your textbook, but they're very important, and we're going to continue using them throughout the rest of this section and throughout the rest of basically your mathematical career. So please make sure you know them. They both have very fun, unique proofs, so also please make sure to try to pause the video and try to prove them and check the proofs with your textbook. The very first additional property is b to the power of 0 equals 1. Basically, any base raised to the power of 0 will always equal 1. Again, a unique proof. It's actually rather simple using one of the previous properties. See if you can figure it out. The second additional property of exponents is b to the power of negative n is actually equal to 1 over the power of b to the positive n. For this proof, you may be able to use this property to help you out. Try it. I would love for us to be able to do one more example together, so let's go ahead and take a look. Here's our example. I want you guys to simplify 100a to the 6th b to the 10th divided by 75a squared b cubed, and this is all raised to the negative 2nd power. Once you have it written down, go ahead and work your way through. You can compare your final answer with mine at the end, but there's a few different paths that you can take to get to the correct answer. So your intermediate steps may not quite match mine, and that's okay if your final answer matches my final answer. Pause the video again until you have that answer. So hopefully this is the answer you got. Again, the order in which you got there doesn't necessarily have to match mine. There are a lot of different orders you can do. For example, I got rid of the negative exponent first by flipping, taking the reciprocal of the fraction that was inside. Again, that's ultimately using that b to the negative n equals 1 over b to the n property. However, I could have simplified first and then taken care of the negative exponent. After I took care of the negative exponent, notice I simplified the numbers. 75 and 100 both have a 25 as a factor, so I divided both by 25 to get 3 over 4. And then I went through and I actually distributed in this 2. Again, feel free. If you want to simplify this first, that's awesome. Go for it. It totally doesn't matter the order in which you do these. When I distributed this 2 into everything, I got a 9 and a 16 for my numerical values, a to the 4th times b to the 6th on the top, and then a to the 12th times b to the 20th in the denominator. And then lastly, I canceled out, basically using that b to the power of n minus m property if they matched on top. I like to think of it if I have 4 a's on top and 12 on bottom, obviously 4 are going to cancel from the top, and I'm going to be left with 8 on the bottom. If I have 6 b's up here and 20 b's down here, I have more down here, which means I'm going to have 14 left after canceling out 6 of them. So again, this is the answer you should have gotten. It doesn't matter the way in which you got there. That's all we have for 3.2. Nice work.